Hi students, today I am discussing about thermodynamics. So in this thermodynamics, in NEET examination, you'll get two questions every year, and in JEE examination also, one question damn sure, and sometimes they'll give you two questions regarding thermodynamics topic in the JEE and NEET itself. So in thermodynamics, first point what we have to identify here, different types of different types of thermodynamic processes. Thermodynamic processes. Different types of thermodynamic processes. In this, the first process is isothermal process. Isothermal process. And the second one is adiabatic process. Now basically I'll give you difference between these two, then we'll go in detail. So the first one, in isothermal process, temperature remains constant. Temperature remains constant. Whereas in adiabatic process, heat remains constant. That is, heat remains constant. Now, second point is, if temperature is constant, as per differentiation, what is the change in temperature? Change in temperature is equal to 0. Similarly, change in heat, this process also is equal to 0. That is, dq is equal to 0. Here dt is equal to 0. Coming to the third point. Change in temperature 0 means change in internal energy also 0. That is, if we apply this for first law of thermodynamics, according to first law of thermodynamics, we can say that dq is equal to du plus dw. When dt is 0, then du also equal to 0. dq is equal to dw since du is equal to 0 when dt is equal to 0. And if you apply same thing in this adiabatic process, so in this dq is equal to again du plus dw. Here straight away the LHS of the first law of thermodynamics will become 0. That is 0 equal to du plus dw. Here work done equal to change in heat or change in work done equal to change in heat. Here change in internal energy equal to negative sign of change in work done. So work done means change in work done is opposite to change in internal energy. Now coming to the fourth point is, what is the isothermal process? Isothermal process thermodynamic equation. Thermodynamic equation like PV is equal to constant, that is PV equal to N or T. N is constant for a particular gas R is always constant, like a universal gas constant, and temperature is constant in case of isothermal process. So PV equal to constant altogether. Whereas in adiabatic process, this thermodynamic equation PV power gamma equal to constant. PV power gamma equal to constant. Here gamma is nothing but a extra compared to the isothermal equation, like a thermodynamic equation, whereas in isothermal process, gamma is nothing but a specific heat ratio. Specific heat ratio. Fifth difference in these two. What is the work done during isothermal process? Work done during isothermal process is equal to nRT log V2 by V1 to the base E. This is the work done during isothermal process. And fifth point in adiabatic process, work done during adiabatic process is equal to nR by gamma minus 1 into T1 minus T2. T1 minus T2. So this is the main difference between isothermal process and adiabatic process. So this is the isothermal process and this is the adiabatic process. Whereas in isothermal process, temperature remains constant, whereas in adiabatic process, heat remains constant, whereas in isothermal process, change in temperature 0, whereas in adiabatic process, change in heat is equal to 0, whereas in isothermal process, if we apply the first law of thermodynamics, you will get dq equal to dw, since du equal to 0 when temperature changes is 0. Similarly, whereas in adiabatic process, if we apply first law of thermodynamics, you will get dq0, therefore du plus dw equal to 0. So here du equal to minus dw. And coming to the fourth point, thermodynamic equation or state of equation, PV equal to constant in case of isothermal process. In case of adiabatic process, thermodynamic state equation, PV power gamma equal to constant. Gamma is nothing but a specific heat ratio, thus is the excess part, whereas in adiabatic process. And finally, work done during isothermal process, W isothermal equal to nRT log V2 by V1 to the base E, and whereas in adiabatic process, W adiabatic equal to nR by gamma minus 1 into T1 minus T2. Thank you, one and all.